Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we have a review of Pythagoras Theorem. So we've already done trigonometry this year. Pythagoras Theorem is complementary to that. So you use it at different times to trigonometry to sort of get the same outcome. So for Pythagoras Theorem, we're still talking about right-angled triangles. Sorry that my drawings haven't got any better. So Pythagoras' theorem is about finding an unknown side in a right-angled triangle. So we also found unknown sides of right-angled triangles when we did trigonometry. To use trigonometry to find an unknown side, you need one angle and one other side. To use Pythagoras' theorem, you find an unknown side when you know the other two sides. So you use it in different circumstances to trigonometry. So we need to know two sides and we can use that to find the other side. So remember, we labeled our triangles such that the longest side, which is always opposite, i.e. facing the right angle, is called the hypotenuse. We label that C and the two shorter sides A and B. So it's important that A and B are the two shorter sides and C is the longest side. So Pythagoras' theorem is that if you have a right angled triangle, then A squared plus B squared equals C squared. That is Pythagoras' theorem. Okay, only works if it's a right-angled triangle. So if the triangle is right angle, then the sum of the squares of the two shorter sides equals the square of the longest side, the hypotenuse. So from that, we can rearrange the formula slightly so we can calculate an unknown side easily. So if you're finding the hypotenuse, which is of course the longest side, you can usually skip straight to this formula, C equals the square root of A squared plus B squared. If you want to find one of the shorter sides, it doesn't matter which shorter side you call A and which you call B, you can use the formula A equals C squared has to go first, minus B squared. So you add when you're finding the longest side and you subtract when you're finding the shorter side. Okay, let's look at a couple of examples. So let's say I have this black triangle and I want to find x. So firstly, we have to figure out, am I finding one of the longest sides or one of the shorter sides? We don't need to get out our ruler and measure anything. That's not going to be helpful. We know it's the longest side because it's the hypotenuse. It's facing the right angle. So we can use this formula here. Now, even though this longest side is called x, that doesn't matter. It doesn't matter what you call it, A, B, C, D, X, whatever, okay? As long as you know that it's the longest side and therefore we need to use the first formula. So x will just be the square root of A squared plus B squared. Adding because we're finding the longest side, put that straight on your calculator and you get 10. How easy is that? Let's look at another example. So in this blue triangle, we're now finding a shorter side. B is one of the shorter sides because it's not the hypotenuse. So now we're going to find B using this formula. So it's going to be the square root of, the hypotenuse has to go first, 20 squared minus 12 squared. If you did square root of 12 squared minus 20 squared in the wrong order, you'd get an error in your calculator because, of course, you can't square root a negative number. So if we put that on our calculator, we just get the number. And of course, you know, if this was in centimeters and this was centimeters, the answer would be in centimeters too. Okay, 16 centimeters. You don't always get whole numbers. It just happened that we did in these two cases, all right? So how easy is that? So I said before, you can usually jump straight to this formula rather than writing out like this. There's one time when you can't do that. That's when you have an isosceles right-angled triangle and you have to find each of the shorter sides. So I'll show you an example of that now. So let's have a look at this question here. The hypotenuse of an isosceles right-angled triangle is 24 centimeters. What is the length of each of the shorter sides? So you might be thinking, well, how can we do this? We actually have to find two unknown sides in this question. And before I told you that you use Pythagoras to find one unknown side. We can do this question though, because the fact that it's isosceles means that it will have two sides of equal length. And of course, they will be the two shorter sides, because the hypotenuse is always longer than the other sides. It's never equal to any of the other sides. So if you want, you can draw a diagram. So it'll look something like this, drawing a right angled triangle, and we know this is 24 centimeters, and these two sides are equal. We know that because it's isosceles. An isosceles triangle has two sides of equal lengths. So if we call this one A, this one here will also be A. So again, we can't go straight to the square root of blah, 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 because there's two unknown sides. But we're going to set up our equation using Pythagoras theorem. So we've got a squared plus b squared equals c squared. But in this case, a and b are the same. So we can just write it as a squared plus a squared equals c squared. Now, of course, in this triangle, c, the hypotenuse, is 24. So I now have an equation that has one unknown. Now, don't freak out. You might be thinking, oh my god, do we have to use quadratic equations because of the squared term? Well, we don't, because this can be simplified easily. A squared plus a squared is 2a squared. They're like terms. 24 squared is 576. I want to get a by itself. I need to undo everything I've done to a. Now, because of BODMAS or BIDMAS, whatever you want to call it, raising to the power comes before multiplication. So I have to undo the multiplication first, because when I solve equations, I undo things in the opposite order to BODMAS. So I divide by 2 each side of the equation. So 576 divided by 2 is 288. So now the way I undo squaring is square rooting. So a will be the square root of 288, which to two decimal places is about 16.97, in this case centimeters. So you don't always get a whole number. All right, there's just one more thing that I need to go through. So the last thing I need to go through is determining whether or not a triangle is right angled. And you can again use Pythagoras theorem to do this. So I know that if a triangle is right angled, then a squared plus b squared equals c squared. The converse is also true. If I have a triangle in which a squared plus b squared equals c squared, then the triangle is right angled. Okay, if a squared plus b squared does not equal c squared, then the triangle is not right angled. So how could I apply this? Well, let's look at a question. Let's just say I draw a random triangle like this, and I say the side lengths are, let's say, 14, 18, and 22. So you might be tempted to look at it and say, oh, okay, clearly that is right angled. But you can't just look at it and assume. What we have to do is check whether or not Pythagoras theorem holds. So I'm going to check whether a squared plus b squared equals c squared. Now, 14 squared plus 18 squared, if I add them up, I get 520. 22 squared is 484. So you can see that this is a little bit more. So is this triangle right angled? No, it is not right angled, because a squared plus b squared does not equal c squared. On the other hand, let's say I had a triangle like this. Again, it may look right angled, but you can't just assume that it's right angled. So let's say that I had, one side equal to 5, one side equal to 12, and one equal to 13. Obviously, this isn't to scale. So 5 squared plus 12 squared, a squared plus b squared equals 169, c squared equals 169. So this triangle is right angled because 5 squared plus 12 squared equals 13 squared. Pythagoras theorem holds, therefore, yes, this is a right angled triangle. All right, I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.